Welcome to week 2. We'll be talking about dictionary, set, and string, and also functions. Let's move along. Dictionary. So if you encountered lists from the previous lesson, and lists are basically a data structure where you store data objects, and dictionary is another data structure as well where you can store data objects. But in this case, when you store a data, right? It's instead of being ordered in lists, it is an ordered collection. Also, it maintains a key value pairing. Um, so example below, let's say student ID number and SSN, order ID, quantity, name, and friends. Another examples you can do is like first name Clark, last name NGO, which is my last name, right? You can also do that somewhat pairing in lists, but it's harder to maintain, right? So we'll be using dictionaries. Uh, they're basically mutable values. It means that the paired value can be changed. However, the key that references to that value is immutable. We cannot change that. Okay. It's also similar to map or hash table data type in other languages. So if you've done Java or C++, you've encountered this as well, right? Keys cannot be duplicated, but values can be duplicated. Right? Here is a good summary of what's the dictionary versus the list. These are the way that you can initialize through direct assignment. And because dictionary also has members or methods, right? They have a dot get. So if you say my dictionary dot get and whatever key, let's say key 1, you'll get A. Okay, so get is basically the way you access a key, one of the ways. Okay, you can also access it by passing in the key inside of a square bracket, okay, enclosed in quotes. It also have other methods such as pop, pop item, and clear. Kind of similar with list, but it has methods to manipulate the list. We have methods to manipulate dictionaries. Okay, go ahead and try this out. Set default is one of the methods that you can use. If you're used to doing coding challenges, you would usually do if in dictionary, then insert in dictionary, right? You can basically get away with just if in dictionary set default so that it sets a default if it does not see it, right? You don't need to add an extra check, and also it won't throw an error in case that you're looking for something that's not there as well, right? Do look up set default. You can also sort this. I think when you sort it, it will transform it into a list. You can go ahead and try it out. And for the demo, please go over these codes. Demo. So one of the cool things that you can do with your dictionary, let's say you have a dictionary with a variable name person, do the dot keys, and you will get all the keys. And if you do dot values, again with the parentheses, right, you would get all the values. This is a good way to, one of the ways to iterate over, let's say, the dictionary keys or the dictionary values. Okay. Code demo, let's see. Sorting a dictionary by key. Okay. Values. Okay. Dot items. Okay, do check it out, right? One of the things that you have to check is if you do, so we mentioned we have the dot keys and we also have the dot values. We also have this dot items. If you do use the dot items, the first variable that you used, whether whatever name this is, so it will first grab the key. And if you put a comma separator and then any variable name, in this case we use values, you'll basically be accessing the values. Okay, challenge question. Go ahead and try it out, and you can come back to me in MS Teams and we can discuss this. So sets, one of the things about sets is it does not have duplicates, right? If you've learned about Venn diagrams before, right, the intersections, right, you can have only A or only B or A and B, right, the intersection. And sets, the important part is it's unordered, it has unique elements. So if you do have a problem you're trying to solve, let's say you have a list of numbers with duplicates and you want to remove the duplicates, one of the ways to do about it is converting it to a set. So it removes the duplicates right away. Okay, let's see, discard, remove, I have those methods, right? So this is like the append, and this is like the pop. Set is mutable, don't forget. Set operations. Okay, this is you do need to learn about the union. Let's say you want to get the, let's go back here. Let's say you only want to get only A and the intersection of A and B. You can get A and B only. You can get only B plus A and B, right? So you need to learn the difference between union and intersection. Union is putting things together. Intersection is basically where they both meet. Okay. These are the different methods, and you can go ahead and look at the top right and go to that references, and it will show you sample codes of how to use it. And as always, you can follow along the code sets. You can iterate over them. For loop works, okay, using the union operator and the intersection operator, right? You can also get the length. Strings. So strings are mutable, but not each character, and they can be accessed with a square bracket, kind of similar with a list. So list has a sequence of elements, right, or values or objects, and string is a sequence as well with characters, right? So basic operators of strings, one of the things you have to know is you can have single quote, double quote, triple single quotes, right? Um, and one of the common ways to print out to the console is the print, but you can also use access and write. Escaping characters is basically you trying to print out a certain characters because that character is a reserved key or character, keyword or character. An example, let's say single quotes. You use single quotes to basically denote that this is a string. So if you do want to print out a single quote, you need to use a backslash and then the single quote, and so on and so forth. Yes, similar to these operations, you can index, you can slice. Indexing, you can basically just use a position, a number, and then you access that certain position in the string. Slicing is, again, when you chop off the string or the list, okay? It has a lot of nifty functions like its upper, its lower. This is a good way to do validation check. Let's say you want to have your users register that email and you don't want them putting an input with uppercase. So you might want to do some check if the user input has a lowercase, right? If it's a phone number entry, you would like to check if it is a digit or not, right? If it's not a digit, then let the user enter again and not let proceed. And if it's a digit, go ahead and accept that and save. You can follow along some of the code demos here again. We do have the split. Okay, the split basically makes it into a list here, right? You can also slice it. And just so you know, if you have a bunch of strings in another list and you want to put them together, you can just do join, right? And again, with slicing, accessing is putting numbers in square brackets. Slicing is when you add columns, right? There are some defaults: the start, the stop, and the step. Okay, so this is a easy way to reverse a string, right? You can also do some replaces and left strip, R strip, and strip. If you've done Excel before, we do have this left and right where you basically cut off the string as well. You can do that, right? Like the white spaces. Okay. Print statements with escape characters and also using tabs and new lines. And this is using the multiple lines with the triple single quotes. And also the triple single quote is also like outside of the print function, you can use it as a doc string to basically help you document stuff, right? You'd rather use doc string if you're explaining something that the person doesn't really need to know what's the intricacies of your program or the certain function, and you want to use the hashtag or pound sign to basically extend the explanation of your function. Just a general guideline. Okay. Now we go to function debugging and logging. Right? Functions, we'll define it. Okay. So in programming, you want to have functions why to have cohesiveness, reusability, organization, readability, information hiding. An example. So let's say I'm a user, right? I don't need to know what this function is doing. I just need to know that it works. An example of that, right? Let's say you have a coffee machine, right? And you basically insert something to that machine. You don't really need to know how the heat level or how it's being mixed. You just want a perfect coffee after you place that maybe coffee coffee thingy that you put in the coffee machine, right? I'm not a coffee person. Apologies, right? So same thing with function. Let's say I have a function that checks if this is a number, right? Or is this a function that returns me the square root of 2, or maybe a function that would um, give me back the square of a number, right? So again, reusability is you don't need to keep writing that logic. You just need to call the function that you have made. That's one. And information hiding is, for me, I just plug in my number and it returns me the expected number. I don't need to know the inner parts, right? Unless I'm someone who needs to debug or code it. An example of that one is when I check your program, if I just run your program that you submitted to me and input some of the numbers and I get what I expect and I don't check your code, that helps me with information hiding that I don't really need to know what it's doing, right? And then again, if I need to check, I do need to check the information. And readability as well, because um, if you don't add reusable code, you'll definitely have a lot of spaghetti code, right? And we don't want that because it will be a big impact to your organization where there's a lot of technical debt because of a lot of janky code. So functions and when to define. I think I mentioned this a lot. You basically create new programs, you avoid repetition, increase the information hiding in OOP, right? So to define a function, you would put a def keyword, so you cannot use def, right, as a variable. So you put the def and space and whatever function name you want. In the example, it's function name underscore name, right? That's a good practice for Python as well. Don't do a function, then capital N, A, M, E, right? The next is you can have that upper parentheses where you can supply an argument. Next is, this is not really part of the function, but as I mentioned, is you can put docstrings, right? Like this one. It might be single or double quotes. Go ahead and check, right? And lastly, the function may or may not return something. Some functions would do an operation and that's it, and some functions would do an operation and return something back to that, let's say, to that line or code that basically called that function, right? Okay, you can have optional, you can have this one, start a function block. Don't forget this one, the column shows you an error all the time. And let's move on. And as we said, you can also return something. You can return a variable that you manipulated. Let's say you passed in a variable and you made some changes and then return that, right? So again, let's say you have a function that squares a number. So you input 2, it becomes 4, right? And you return that 4. If you input 3, you basically return 9. It's 3 to the power of 2 is 9. Okay? And again, when you have a return, it also signifies the end of the function call, meaning it will now step out of the function. It's done, right? Okay, next. Arguments. Again, if you do have an argument, you can use or not use the one that you passed, but most of the time when you pass an argument, you want to use it because what's the sense of adding an argument and then you're not using it? Another way that we can a synonym to arguments are basically parameters. Okay, so as you can see, they pass name, and you can access the name variable to print it out. Okay, same goes for here. To same variable names, go ahead and check it out, and what would happen. Scoping, right? There's local, global, block scope, right? And as you can see, we have the built-in, global, enclosing, local, right? So global, again, it's something that you defined, and it's not in any of the scope, meaning not inside of an if statement, not inside of a for loop, not inside of a function, right? Local, again, that's something that's inside of those, an opposite of that one, right? And we'll go down first. Global keyword. A variable in one local block cannot be accessed in another local block. For example, you have two functions, right? A function has a variable of name, and then in the other functions, you are trying to call that other variable. It would not work. You can, yes, use the same variable name, but again, it would have different values. It will not inherit or pass down that information. Okay, for non-local, it can be used in nested function blocks whose local scope is not defined. Positional arguments. So positional arguments are basically when you have the user input, let's say, a bunch of numbers, right? And you grab that positions, right? If I input, let's say, 215, and I have positional arguments there, the first, the second, the third, meaning the 200 and the 10th and the 5, right? And as you can see, you can also check the arbs and kwargs where you basically have that, and it will basically check each of the positional argument, and basically you don't need to have to add every argument in your function or in your expected input. For example, let's say you have a program that asks for two separate numbers, let's say 24 and 12, right? What if it changed, right? The business guy said, I want to add 3 numbers, and the next time around, I want to add 5 numbers. So instead of reworking your input or your function, right, you can just have an args, this one, so that it will take any number of argument and it will pass to that function. Keyword argument. Okay, again, go ahead and check this out. If you have questions, ping me in MS Teams. More keyword arguments. Arbitrary arguments. The use of asterisk. So just to correct myself, if the args, it helps with the complex numbers to get any numbers of argument. You can do the same thing with the arbitrary arguments. But again, it uses the asterisk and you can use any variable name. Kwargs as well, the keyworded arguments. And below the concatenate, check what's wrong with the following statement and ask me in MS Teams. Passing by reference versus copy. So passing by reference is basically when you pass something, and let's say you pass an array or a list, and you pass that variable name, you pass the address. Again, the array or list, it's stored somewhere in the memory. It is referenced somewhere in the memory, right? So if you pass by reference, you're passing that memory location. And what happens after that is if you do any manipulation, you're basically manipulating the original list or array. Because again, you're manipulating the one that's stored in the memory. However, we do want to avoid that. We don't want mutability in a code most of the time. So we do want to copy, right? So the best way to do is you copy that array or list, and then you manipulate it so that when you need to call that original array or list, it retains its original value. Okay? And here's some code demo to play around. Yep. And if you got interested and want to learn more, go ahead and check the Python and then check Python copy library and learn more about it. Right? Okay, division operator. Lambda function. Lambda function, another elegant way to do something. It's basically a function without a name. It is synonymous to other programming language where they also call it anonymous function, right? Sometimes you don't really need to name that function, right? You just need that operations to happen, right? So an example of this one, sometimes you want to define, oh, this function is adding it by 10. So you have a function named adding 10, right? But if it's something that, let's say, just part of the operation of another function and you don't really need to mention what it is, so you can use a lambda. So lambda looks like this now, right? Lambda, and then the argument, and then the argument plus the value that you want, and it's being assigned to the x. So x is now a function. So to call a function, you have the open parentheses. So if you do see a variable, and then the variable has an open parentheses, again, like in this example, requires an argument, it means that this variable is a function, right? Again, they're similar. Simple and quick fix for function definition. Use it as a template function for future issues, aka functional programming. As you can see, it's so elegant, right? So this is it for this week. Please work on your assignments and please let me know if you do have questions. Until next week.